Hi, welcome back to another video. So in the previous lesson 7, we learned about classes and we learned different concepts related to class. So in this video, we are going to start about the 4 pillars of object-oriented programming. Now, object-oriented programming is basically, in simple words, the concepts and the techniques with the help of which we can translate and mimic the real-life objects, real-life things into our programming language. For example, if I tell you, write a code that demonstrates the characteristics and attributes of the car. So you will create a car class, then you will create objects, then you will have some member functions within it, then you will have some attributes within it. So what it is the OOP, object oriented programming. Now object oriented programming, whenever you study it in any language, you have the 4 pillars of OOP: encapsulation, abstraction, inheritance, and polymorphism. In this video, we are going to get the idea and the basic concept of encapsulation and abstraction. So what is an abstraction? So basically, abstraction is the technique. Abstraction is such kind of a technique with the help of which we focus on what the actual object is doing rather than how it is doing. For example, within a car class, let's have a function like going car forward. Now the car is going forward, that is abstraction. Forward is abstraction. We don't know what is the code behind it. We don't know the complex operations, the complex mechanism behind the car is going forward. We only need forward. So it provides a good name, a suitable name to represent that functionality, and whenever the user uses and wants to use that function, it uses that keyword or that attribute name or that function name to perform the functionality, okay, rather than going into the details of how it is being done. Now what is meant by encapsulation? Now encapsulations, in simple words, bundling of data under one name. For example, if I collect all the attributes, all the characteristic of a certain thing, like a car, we are discussing the car object, so it is like I'm sure that most of you guys will understand this example, that if we have a car, we have some different attributes of it, characteristics of it, and they all are encapsulated within one class car, and they can be accessed with the instance created as object 1, as car 1, etc. Okay, so this is the basic idea behind encapsulation. So this can be demonstrated over here with the help of this figure. You guys get the idea of what is encapsulation and data hiding. With the help of encapsulation, with the help of data hiding technique, we can mimic the real life objects, as well as that it can be very useful in lengthy codes. Okay, so for example, you created a class, and in class you want to hide some data of avoiding people getting the direct access to those attributes, so you keep them in the private section. But whenever providing such kind of data that you want anyone to easily access it, then you put all of those stuff within your public section. So this is the basic idea behind the encapsulation and abstraction. So I hope you guys get the basic concept. Now let's discuss it within our code blocks terminal, where we will see and demonstrate it and understand it with the help of real life example, and that example is going to be a car class. Let's go. Alright, so here I am in my code block. So first of all, let's create a class name as car. Okay, so here we have a class name car. Now let's have some private members. So within private members, I will have a private keyword. Now in private keyword, what I will have a string chassis number. I don't want anyone to know my car's chassis number. Okay, and I also want to have string owner name. Owner name. Okay, So these are two private members, chassis number and owner name. They are kept in the private section. Now what we are going to have in a public section, we will say the car name. So we will say string company. We will say company, okay? Because it is demonstrated on the car external body that everybody knows that what's the company of the car. Now let's have the integer model year, okay? Then let's have a like a number plate, okay? So integer register, okay, or num plate, okay? So these things are actually available to the public direct access. So whenever a car is moving in front of you, you can easily guess that Toyota is the manufacturer or Honda is the manufacturer. Then if you just have some little knowledge, you can also guess what year model is this, okay? So it is 2022 or is it 2015, whatever it is, okay? And the number plate is also physically and publicly demonstrated. So like LEH919, whatever the number plate has the number, it is publicly available and displayed, okay? Then car's chassis number, it is not publicly displayed. It is displayed, but you have to do something. You have to open the bonnet, or there must be somewhere on the engine or somewhere else on the car. You have to look for it. Now different cars are moving in front of you, but you never know the owner names unless you are somehow close to it. So what we are doing here, that we are creating a real life scenario, real life object in our programming language. What is it, that real life object? The real life thing is the car, and the real life attributes are private members like chassis number, owner name, and company model year, num plate. So these are the attributes, and on the basis of level of accessibility, some of them are being kept private and some of them are kept publicly available, okay? So I guess you guys have got the idea of private and public more clearer now, okay? And you know the purpose and you know the how it's done, okay? Now let's have a look at some methods, or simple words, member functions. Let's create a member function as void forward, okay? So we have a member functions as a void forward, okay? We have somehow some keyword of forward, so we will use FORW only. And within forward, I'll write car is moving forward, okay? And then another function, we will create 3 more functions that will demonstrate the other directions as well, okay? So let's just paste all of this code over here. Then we will say reverse, reverse, okay? And we will write reverse over here, okay? Now here we will have left and left, okay, and right here, and we will have right here as well. All right, so we have some functions over. Now what you guys see, let's suppose that there is some complex code behind it. So complex code, okay, and we will just copy this and paste it over in the other member functions as well. Now let's suppose each and every direction, for each and every direction we have some complex code. Like for going forward, the gear is shifted to D, then there is something happening like acceleration and things doing in the engine. So all of that complex stuff is behind this forward keyword. Now within your main function or anywhere else, whenever you call the member function forward, what happens? The car moves forward and the user wants the car to move forward. Now what is actually happening behind the forward? The user has no concern with it. The user has no concern with that complex procedure, with that complex piece of code. The user only wants to utilize that specific keyword or that specific attribute or that specific function for its purpose. So for forward, he will use the forward keyword. For reverse, it will use reverse keyword. For right, it will use right and left. So this is what we mean by abstraction, that we hide how it's done. The only purpose and the only thing that is the only thing that user wants is the functionality. Now here I guess you have got the idea. It focuses on what an object does rather than how it is done. So whenever you call the forward function, the object goes forward, but it doesn't tell you how it's going forward. Okay, it has been hidden within encapsulation. Now this is the whole code. Within this code, you see this class. This class demonstrates the concept of encapsulation. How? Because we have encapsulated, we have collected, we have binded different attributes, functions, member variables, member functions, methods within just one simple name, car. Okay? This has been encapsulated. Now these functions demonstrate the concept of abstraction. Okay, so now let's go and have another practical look. For example, here I create a class by the name of car, which is actually already created. Here I am going to declare car1 is our first object. Now this car1, this little name has all these characteristics, okay, has all these characteristics because these were encapsulated within the class name car, and that is a user defined data type. And whenever you declared a variable with a specific data type, you get access to all its features. Okay, so we got access to all of these things. Now whenever I print car1 dot forward, let's go and have a look at the printing message. Now as you guys can see, there is a message car is moving forward. Now assume that car is now moving forward, but you guys see any other piece of code here, any other complex thing on your output? No. The only concern the user has is that car should move forward, and the car is moving forward right now. If the user wants to go car on the left side, he will call this function. Now the car will go on the left side as well. Now the car is moving forward as well as on the left side. So the only concern, the concern of the user, the concern of the driver, the concern of the passenger is that car is moving forward, left, right, or backward. The concern of the user or passenger is not that how it is going forward, how it is going backward, what is the mechanism behind it. Only thing he has is the gear, the shifting gear, the steering wheel, the accelerating. With the help of all those gears, he applies these functions forward, left, right, etc. And what's happening behind it physically, it's not of his concern. Okay, so this is the basic concept of abstraction. And the car qualities, attributes, or those driving forward, backward, left, right, and switchboard, dashboard, all of these things have been encapsulated within the car class. So that is the demonstration of the encapsulation. Now if you want to access these private members, you will create some accessors and getters, and if you want to have a display of these things, you can demonstrate a very good function over in the main function or outside function to display all of these. So I'll recommend you guys to design this car class and to modify it and give it a look more practical and more appealing to the user. Okay, so that is going to be your homework as well for more practice. And I guess you guys have got the basic idea of these two concepts, encapsulation and abstraction. In the next video, we will perform another practice problem, and I hope you guys will be good to go with these concepts, encapsulation, abstraction, and the concept of the classes. Okay, so it's done here in this video tutorial. I'll meet you guys in the next one.